Good evening, everyone. Today is September 19th, 2019. Welcome to another episode of my machine learning journey. So today I would like to share a topic, which is topic modeling. So for each of these of my videos, I'm gonna follow the tech leads style, which is also a software engineering design pattern, which is single responsibility. So every one of my video will only focus on one thing instead. So that the theme for this video is about topic modeling. So for all the topic modeling, to me, my understanding is it should be firstly about partition of a big corpus. So let's say that you have a news article, and this news article talks about a few things. So for say, it talked about Justin Trudeau, which is very hit news for today. But then in this news article, it also then talks about election. And then it also got covered on, let's say, racial issues or gender issues. So you want to be able to find all these components or compartments of the corpus, so which we call, these are the concept groups or topic groups. So therefore, you partition your news corpus into several themes. And then in these several themes, then you want to be able to say, so what are the items form these each individual topic theme. It's also like market basket, also like your grocery list or your expense list. So for your monthly expenses list compile, you want to be able to partition your monthly expense receipts into, say, groceries, recreation, cosmetics, and so on. So these are all the big topic groups that you find in your expense list. And then in each of these smaller basket, these smaller theme or these smaller topics, then you want to be able to say which items that are associated together to form these each individual basket or topics. So therefore, the first thing that we need to do in topic modeling is, how do we find association? So in your whole expense items, so you want to be able to group which items are actually related to each other. And therefore, when you find all these small clusters, then you can then define, okay, when I find all these associated items, and then I define this group, this cluster is my grocery cluster. And then that cluster, those related items form the second cluster. And that cluster is for my recreation expenses, and so on. So I would like to introduce today one metric to define the association linkage or the association strength of two items is point-wise mutual information. So point-wise mutual information is defined as the odds of two items occurring versus them being independent. So mathematically speaking, it's using the joint probability. So the probability of item 1 and item 2 occurring together versus the product of the two marginal probability. So this measures, do events X and Y co-occur more than if they were independent? So if they were independent, then the joint probability will just be the same as the product of the marginal probability. So therefore, the point-wise mutual information then will be 1, right? And then, so for point-wise mutual information, then it will be taking the log 2 of this odd ratio. So therefore, if it's perfectly independent of each other, then we said that then the odds ratio is 1. Then when you're taking the log, then it becomes 0. So which means that then they're completely not relevant with each other. So this metric, it's based when you see that it's actually measuring the frequency of items occurring together, so it's basically measuring the frequency of co-occurrence, right, over like marginally occurring. So but then using the odds ratio instead of just purely measuring the frequency of co-occurring, the benefit is, so what is this PMI good for? So it reduces the effect of frequent words, frequent contact words. So let's say that in English corpus, the word the or to are just frequent words. So they appear anywhere. They occur very generously, right? So therefore, then you can see this word will just co-occur with, let's say I'm querying a word, milk, right? I want to see which items are relevant to milk. But because the is just appearing everywhere, let's say it appeared in front of milk, so the milk, but then it also it also appeared in front of other items as well, right? So can I just say that because the and milk co-occur almost all the time, that I see these two items happen almost all the time? Can I say that milk and they actually are similar things? No, right? Because of the nature of the word the, it's just appearing everywhere. It's not only co-occurring with milk, but it also co-occur with other things. So therefore, if we nominalize the co-occurrence of the two items by their product of individual marginal probability, then we will scale down the effect of this frequent word, because the probability of you seeing the is just very high in general. So therefore, it's not that unusual to see it co-occur with any other thing. So therefore, you divide it by your co-occurrence probability by so if the probability of your frequent word is higher, then your PMI is lower, right? So therefore, it's good for reducing the effect of stop. So these kind of words, frequent words that they appear anywhere in English, is also called stop words, right? So PMI is good for reducing the effect of stop words, but it also has its disadvantage, because for anything you cannot have it both ways. So for say when you scale down the PMI by dividing the marginal probability, then you will also suffer the disadvantage that if you have an infrequent word, right? Let's say something it's just very rare to see it, which means that the probability of you seeing it individually is very low. So therefore, the PMI for these kind of context word is just going to be very big, very high, right? But as we know that, these when something rare happens, and then but I happen to see this item with another item co-occur together. It's also a rare event. It's also very infrequent, right? So therefore, my numerator of co-occurring is a rare event, just because one of them is just rare to see in general. So therefore, you cannot, in this case, the PMI is high, but you cannot say that these two items are related to each other, right? Because you are lack of information. You need to, you need more information to make that conclusion, right? So therefore, there's something that you need to do about it, which is you should just smooth. So this is called a smoothing effect. So you should just nominalize the marginal probability of the context words to raise to the exponent of 0.75. So when you do the number counts of the marginal probability, then you should raise that count to an exponent of 0.75. So therefore, if you have a very rare event, then the marginal probability will actually be higher. So therefore, the PMI will be lower for the infrequent word. And then also, so this is one thing, one disadvantage of PMI, which is it bias to the infrequent word. But what is it good for is it can reduce the effect of frequent word. So, but then there's the second disadvantage of PMI, which is because you are producing a generalized rule. So therefore, the corpus of you to calculate this PMI need to be really big. So which means that you need to see enough basket, like let's say, not even like Canada, right? Like let's say like the whole North America, right? Which means that you are forming a general rule. So you cannot come out with a conclusion or a statement if you are just deriving this from a specific group, like a biased group. Like for say a certain group, if you're generalizing all these co-occurring things, you cannot really generalize this rule to like to a more to an overall population. So which means that you need a big corpus to derive these rules. So there's a reference which is in Jarofsky's slides. So Professor Jarofsky wrote a book, which is a classical book in NLP called, I believe it's called Language and Speech Processing. So this is one of the slides, which is in vectors semantics. So let's go to the section which talk about point-wise mutual information. So here is the section in this slide about point-wise mutual information. So this is officially how the point-wise mutual information is defined. So you have a word and then you have a context word. So you are finding what are the contexts that are related to my word, right? So so here is another one talking about smoothing the PMI by exponent to remove the bias towards infrequent word. So here we go. So you can see that for word and then the context that you should, so for the counts of the context, you should raise to an exponent of 0.75 to calculate the marginal probability of the context word. So how I encounter this PMI is they also use this method to form word vectors because this basically is about representation learning, right? So you have one thing and then you want to define this thing or you want to represent this thing. So I have my item milk and then I want to define what is milk. So how do you define this word or this item milk is by you find all the associated, all the related things which are related to milk. And then you use all its neighbors or all its related things to define it. So therefore, for milk, it's related to cream, let's say. It's also related to cheese, right? And so let's say milk and cheese have a PMI of 0.7. And then milk and cream has a PMI of 0.8. So then now you have a vector of 2 dimensions of cheese and cream to represent milk. So therefore, you use the PMIs of your word with its related items, the measure, to represent my milk. So therefore, you have formed a vector that represent milk using the dimension of cream and cheese. So actually, there's is thread. The post says that, you know, if you have, you know, a big enough corpus, you probably don't even need word2vec or glove or any of those to train those word vectors. You can just use this PMI metric to come up with your word vectors for your word. But after you form this PMI, you also need to use singular value decomposition to find a more dense representation vector for each of these words, right? So I happen to use this method on a collection of job postings. So the job postings is on Kaggle from all the online job postings in the United States for 10 years. And then when I use this method, it happened to be the results are very good. So it can find that yoga is related to Pilates, like some, like for those very domain specific, like very technical things that you can actually all find the relations between each other. So if you're interested, feel free to try on your own data set, but just remember it need to be a big enough corpus that it can, come up with a general conclusion. So not just like a specific data set that is biased, right? Like the association, the relationship, or just biased to that particular group. So another thing, but I would like to add, like I'm very curious, is because this mutual information is only a pair-to-pair relationship. So which means that it's a bigram, right? It's a bigram relationship. So I'm wondering then, is it the, trigram or more combination of things can be formed? Let's say I'm only using C to define A or separately, and B to define C separately. But if I see, let's say, B and C together, does it change my definition for A, right? So let's say that, to detect sarcasm, right? So if you just see, two bad words, but it does not necessarily mean it's a bad thing, right? Maybe you're just using sarcasm. So if you see two bad things separately, maybe it means bad. But if you see two things happen together, so a combination of these two bad things, maybe it means a good thing, right? So that's what I would actually like to explore next, about beyond just pairwise mutual information. So I'll keep you tuned. Thanks for watching for today's episode, and I'll tell you more. So if you like the content, so please subscribe and like my video, or you have any ideas or comments, feel free to leave it below the video as well. Thank you. Have a great night.